Hi, welcome back to my channel, Geophysics for Everyone. I do hope that you enjoyed the video. Thank you. Today we are going to talk about the elemental composition of rocks. This video is part of a series that is intended for courses at Institut Teknologi Bandung that is called Elementary Geophysics. This is given for second year students. So, what are the elements in rocks? Based on their abundance or properties, the elements in rocks could be divided into what's so-called major elements, trace elements, the rare earth elements or rare metal elements, and radioactive elements. So, what are the major elements? In simple terms, the major elements are those elements who has concentrations of 1% or more in rocks. In the Earth's crust, the major elements are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. In some cases, other elements could be considered also as major element. For example, the titanium is a major element when we discuss about igneous rocks. The classification of rocks are often conducted based on the compositions of their major elements. And what are the trace elements? In simple terms, trace elements are elements of rocks with concentrations of about 0.1% or 1000 ppm or lower. These elements include nickel, chrome, zircon, etc. What's so special about trace elements? Trace elements are sensitive to geological processes, so that their composition could be used in many aspects, for instance, to differentiate magmas or to determine the depth of magma chambers. In sedimentology, the composition of trace elements would be used to infer the source rock of the sediments. And what are the rare earth elements, or REE? The rare earth elements are the 15 elements that are grouped as lanthanides in the periodic table, plus scandium and yttrium. Scandium and yttrium are considered rare earth elements because they tend to occur in the same ore deposit as the lanthanides and they exhibit similar chemical properties. Now, this is interesting. The rare earth elements are actually not really rare. They are often dispersed due to their chemical properties. Therefore, it is rather difficult to find them in concentrated forms. In most cases, the composition of each element is not that important. The most important is the pattern or overall composition of these 17 elements. This pattern or overall composition of the 17 elements are often used to determine the provenance of sediments or the petrological mechanism of a rock. The rare earth elements are much sought after because of their roles in advanced material and technology. For instance, one of the strongest permanent magnet is neodymium magnet. So, what are the radioactive elements? Actually, there are numerous elements that could be considered as radioactive. Many of the heavier elements could be considered as radioactive elements. But the three most abundant radioactive elements are potassium, uranium, and thorium. Concentration of radioactive element varies between rock types. Among igneous rocks, granite has the highest concentrations of radioactive elements. Shale, on the other hand, has the highest concentration of radioactive elements among sedimentary rocks. Radioactive elements and their isotopes are important in absolute dating of rocks. Dating methods are mostly based on these radioactive isotopes. In the next video, we are going to talk about the physical properties of rocks. Thank you for watching. I hope you enjoyed the video. I'll see you later. Bye-bye.